My name is Songchoi Jung. I'm working at the HEAT Lab in New Zealand as a postdoc. I'm happy to give a presentation about our research. The title is The Impact of Multisensory Stimuli on Confidence Levels for Perceptual Cognitive Tasks in VR. I'm going to give a talk with this order. In our daily life, we are confronting many situations which require perceptual cognitive load. For example, sports, cook, and location searching. In such a case, the right decision should be made after we account for all of the information. Though this statement is more close to the cognitive-related work, still perceptual information is needed, and we are dependent on our visual, audio, tactile, smell, and even taste feedback in our life, which depends on the task type of course. Similarly, such a perceptual cognitive load required task exists in the virtual environment. For example, pilot training, medical training, and virtual cook training. However, do they really confidence what they decided in VR? Since most VR setup only provides vision, audio, or at best small tactile feedback, the sensor feedback is missing compared to the real-world experience. To address our conjecture, we set a research question, that is, does multisensory feedback enhance subjective confidence in the decision-making related task in VR? To address the research question, we choose a location searching task, since it requires vision, audio, tactile, and even smell depend on the location. For example, if we have an appointment to meet in front of a lemon tree near a house as we see the note, then the tree, house, and even smell can help to have strong confidence on the decision. We used a 2x1 within subject design with one independent variable, the VR system with 6 dependent variables that are confidence level, consume the time for the given answer, and the correct answer ratio, sense of presence, cyber sickness, and user preference. In multisensory VR, we provided vision, audio, wind, vibration, and smell feedback while we providing only vision and audio in typical sensory VR. To address the research question, we set 3 hypotheses that, first, MVR will result in higher confidence levels and faster response times than TVR. Second, MVR and TVR will result in similar correct answer ratios. Third, MVR will result in more positive subjective feelings in terms of a higher presence, less cyber sickness than TVR. We asked the participants to experience several virtual environments that were rendered with 2 types of VR feedback systems for the same environment. The island scene contained 4 trains, 2 orange trees, 4 helicopters, and a waterfall scattered across it. First, a participant was located in a darkened space, and we provide description about the location, and after confirming the description by the participant teleported to a certain place. Then they were asked to choose whether it is correct place or not compared to the description through the yes or no interface using a Vive controller. Then they were asked to report their confidence level using a vertical gaze bar using the same Vive controller. We adopted a signal detection theory with a 2 alternative. First choice, the participant should choose if the place is a description matched place or not on the 2 conditions that were sensory matched or mismatched in either MVR or TVR condition. We differentiated the sensory component combinations and coded as we see in this slide. For example, for the visual components, we prepared a helicopter train, orange tree, and waterfall with glasses. Here's the used combination of the sensory component in this study. For example, script number 2. You are in a scene where there is a train moving. Then we provided train audio, tar smell, wind blowing, and the rumbling vibration in the matched condition in MVR, while we missed some feedback in the mismatched condition in MVR as well. Similarly, we variated the feedbacks, but we only handled vision and audio feedback in TVR condition. We implemented a client and a server model as a basic structure. The system features flow vibration feedback, wind feedback, and the synth feedback, matching the visual and the audio feedback. The client model rendered the VR environment and the data logging, and the server controlled the additional sensor feedback for wind, smell, and the flow vibration. For flow vibration, we attached the 4 speakers underneath the floor and sent the audio signal. For wind, we used the brushless DC fans, which we can control the speed from 0 to 255. For smell, we attached a USB aroma diffuser to a dedicated fan. After sending a signal, the USB diffuser started heating, and we could deliver the scent to the user who sits in the center of the cage. Empirically deciding on an effective strength of a formulated odor is not intuitive compared to other sensory modalities due to the complex human nasal system, air conditioning, and the individual health condition. To minimize odor detect error, we conduct a pilot study with 10 male and 6 female participants to decide the odorant intensity level in the same experiment condition. We confirmed the required number of participants using power analysis, and we needed to have a minimum of 15 participants. We recruited a new group of the participants, and a total of 17 participants included in the study. Here is the procedure of the study. After we gave informed consent, and we asked to fill out demographics. The participant had their instruction, and we equipped the devices to the participant. After participant had their test trial, they conducted the study with the first condition, and we asked the participant to fill out the questionnaire, and we provided the break time. After that, participants run the study again with a second condition, and we asked again for the questionnaire. After that, we had a short interview with the participant, and we ended the study. Here, I would like to show a video for the whole procedure of this study. In the darkened space, participants had their instruction about the study. And the participants were teleported to a certain virtual environment on the virtual island. And the participants have checked if the place is matched with the description. After they confirm the yes or no, and they provide their confidence level using the vertical gauge bar. And then this is the second example. On the waterfall, and then we differentiate 8 particular virtual environment, virtual location. And then here is how we deliver the flow vibration. We just use the water in a cup, and this is the pattern of the vibration for the helicopter. This is for the train one. And this is for waterfall. So here's the result of the confidence level. There was a weak negative correlation between time lapse and the confidence level. Increases in time lapse were correlated with a decrease in the rating of a confidence level. TVR shows a higher confidence level than MVR. Due to the raw complexity of the task, we found a ceiling effect from the result. We found that the time consumption fails to reject the null hypothesis between the two virtual reality system types, but loosely support the difference still, and limit a higher time spending on the MVR condition than TVR. When you test for all items at the 5% significance level, since the Anderson-Darling test rejected the hypothesis of a normality at the 1% significance level in our dataset, we applied. The subjective questionnaire revealed that the sense of presence differed significantly between the two virtual reality system types and revealed a higher presence for the MVR than TVR. We did not find a noticeable difference in first choice ratio from both systems. We did not find a noticeable differences between the VR system and both systems provoked a slight self-sickness. All of the participants stated that they preferred to have MVR, since it made them feel as if they were in the virtual environment more immersively compared to the TVR system. Here is a summary regarding our finding. We found the benefit from the multi-sensor VR system over the typical virtual reality system in terms of the sense of presence and the user preference. However, MVR and TVR shows a similar level of self-sickness. Thus, we conclude that our findings just partially support hypothesis 3. In contrast to our hypothesis, the participants showed higher confidence in their answer in the TVR system. Also, we found the time duration was significantly higher in MVR. Thus, we cannot support our hypothesis, the first hypothesis, which is MVR will result in higher confidence levels and faster response times than TVR. Regarding the confidence level, we conjecture that higher cognitive load, which comes from multiple sensor feedback, worked negatively in MVR condition. As regarding the correct answer ratio, we found that complexity of this task was easy, and thus the correct answer rate was high and similar in both MVR and TVR. This is our take-home message. From the research, we suggest that high-fidelity multisensory rendering of the virtual environment might not be appropriate for specific applications or tasks which require a raw level of perception and cognition. However, high-fidelity multisensory will be required in the training area, which requires a high level of immersion. In this study, we had a technical limitation. The aroma dispenser had a delay for evaporate smell, and some participants had a difficult to identify it. Similarly, some participants had a problem to distinguish the vibration type. Lastly, some participants was unfamiliar to use a vibe controller. In the study design, the perceptual cognitive load in the task was the level was lower than our expectation. To wrap up, we investigate the impact of a multi-sensor feedback in VR in terms of a confidence level, mainly compared to typical sensor VR system. We provide the vision, audio, flow vibration, wind blowing, and smell feedback in the study. We found significantly higher sense of presence and user preference in the multi-sensor VR system, but the confidence level was low. Here's our contribution of this work. We showed a state-of-the-art technique to deliver diverse levels of sensor feedback at once. And this is the first approach to study the confidence level with multiple sensory feedback in VR. As future work will replicate of the same experiment with the only visual feedback and compare it to more sophisticated sensory feedback in VR, which can provide a more clear result in terms of competence level. Thank you for listening. I'm happy to hear your question.